A situation that can sometimes come up when factoring polynomials is a lead term that is negative, and that does have to be dealt with in a particular way. So first of all, the definition of a lead term is the lead term of a polynomial is the term with the highest degree. So if you look at each individual term, if there's a single variable, you just look at the exponent of the variable. Constants always have a degree of 0. If you have multiple variables in individual terms, you do the sum of the exponents, okay? So make sure you remember how to find the degree of individual terms and basically the degree of the polynomial. So the term with the highest degree, that's the lead term. If the lead term is negative, you do need to make your GCF negative. So that's what we're talking about here. So when the lead term is negative, make the GCF negative, and then just use extreme caution with your signs. Otherwise, the process is the same. We find the GCF, we divide all terms by the GCF, and then the final answer is going to be the GCF times whatever you get when you divide. So that quotient. All right, so let's look at example 4. Example 4 says factor out the GCF. So if we look at the first term, it has a degree of 3. The exponent on the variable term is 3. The second term, 16x squared, has a degree of 2. So the lead term is negative 20x to the third. Since the lead term is negative, we automatically want to make sure that our GCF is negative. Okay, now looking at 20 and 16, I'm going to start with 16. Is 16 a factor of 20? No. So then we want to start looking at other factors of 16. So we would start with 8. Is 8 a factor of 20? No. So then we want to go to 4. Is 4 a factor of 20? Yeah. So 4 is going to be the greatest common factor as far as the variables are concerned. And remember, because our lead term is negative, we also want to make the GCF negative. So far our GCF is negative 4. Now we want to look at the variables. And remember, when you're looking at the variable terms, the variable part of the GCF is going to be that variable with the lowest exponent. So right off, I can say, okay, it's going to be x squared. So we have to remember we're looking for the largest number of variables common to each individual term. Well, we have 3 x's in negative 20x to the third, but we only have 2 x's in 16x squared. So the greatest number of x's common to both terms would be 2. So that makes our GCF negative 4x squared. So I'm going to go ahead and kind of prep for my final answer. I know my final answer is going to be the GCF itself times the quotient when I divide the polynomial by the GCF. So I'm going to go up here and I'm going to divide each term of the polynomial by the GCF. So for the first term, negative 20 divided by negative 4 is positive 5. And then x to the third divided by x squared. Remember, that's a quotient rule. We keep the base of x and we subtract the exponents. 3 minus 2 is 1. We don't write the exponent of 1, but no, it's there. Finally, for the last term, 16 divided by negative 4 is negative 4. And then x squared divided by itself just becomes a 1. So our final answer is negative 4x squared times 5x minus 4. And I'll go ahead and show you how to check this one, and then we won't check the last two. So if I wanted to check this, remember, we're basically just undoing the distributive property. So we want to take our negative 4x squared, distribute it through 5x minus 4, and see if we get what we started with. So negative 4x times 5x, well, negative 4 times 5 is negative 20. X squared times x, that's a product rule. We keep the base and we add the exponents. 2 plus 1 is 3. And then negative 4x times negative 4, well, negative 4 times negative 4 is positive 16. And there's nothing to multiply with the x squared, so I just bring it over. And if you look here, this is exactly what we started with. So just keep in mind that you can always check your answers when you're doing this factoring, okay? Let's look at part B. First thing I want to do with part B is I'm going to go ahead and write it in what's called standard form. So as long as you just have a single variable present or a single type of variable, so in this case all x's, we want to write this in standard form by going highest degree to lowest degree and then end with your constant. So to put this in standard form, I would get negative 2x squared plus 4x plus 8. My lead term is negative 2x to the third. So the first term, or 2x squared, the first term has the highest degree. So the first term has a degree of 2. The second term has a degree of 1. And then remember, constants always have a degree of 0. So negative 2x squared is the term with the highest degree. So because of that, being negative, we want to make sure our GCF is negative. Okay, so let's look and see what our GCF would be. We always want to start with the smallest coefficient, which is 2. Is 2 a factor of 4? Yes. Is 2 a factor of 8? Also yes. So we know our GCF so far is -2. Okay, then we have to look at the variable. Do all of these terms contain a variable? Well, no. So 2 of the terms contain an x, which is great, but that third term doesn't have an x in it, so our GCF is just plain old -2. Okay, so I'm factoring out a -2. The final answer is going to be the GCF of -2 times the quotient when we divide everything by -2. So -2 divided by -2 on the first term is just +1. 1 times x squared is x squared. Positive 4x divided by -2. Well, 4 divided by -2 is -2, and then just bring down the x. And then 8 divided by -2 is -4. So that would be our final answer. All right. Finally, for part C, this one is already in standard form. Okay, so we've got our degree 2 term, our degree 1 term, and then our constant. The lead term is -3x squared. And since the lead term is negative, my GCF must also be negative. So let's start with the lowest coefficient, which is 3. Is 3 a factor of 6? Yes. Is 3 a factor of 12? Also yes. So my GCF so far is -3. Let's double check and see if there are going to be any variables a part of the GCF. Well, the first two terms have an x, but the third term does not have an x, so we cannot say x is common to everything. So our GCF is just plain old -3. So my final answer, remember, is going to be my GCF and then the quotient after I divide the polynomial by the GCF. So let's see what happens when we do our division. Well, -3 divided by -3 is +1. 1 times x squared is x squared. 6 divided by -3 is -2, and then there's nothing to divide with the x, so I just drop it down. And then finally, -12 divided by -3, that would be +4. So there I have factored out my GCF. So understand that if your polynomial has a negative lead term, your GCF also needs to be negative. It's just kind of how we do it in math, okay? Last up, we will talk about factor by grouping.